Hi guys, welcome back to Diane's POV podcast. My name is Diane, and I'm so glad to have you guys here with me. Thank you so much for joining. So let's get into the episode. So if you are in the health and wellness community, you've probably heard that our generation is aging faster. And there's so much research to back it up as well. And you can kind of see like people in their early 20s and 30s struggling with conditions that you usually see in older adults. And I honestly found this really interesting personally because I was like 3 years ago, I was dealing with this uncontrollable cough. It wasn't COVID, I promise. And it took me about 3 years to actually get a diagnosis. But the first time, after like a year of doing tests and trying out medications and stuff, my doctor at the time said that I had COPD, which is chronic obstruction pulmonary disease. And I was like, I guess, like, obviously, sometimes you don't like try to like ask your doctor like more questions about it, stuff like that, just because it's like a little awkward. So I decided to do a little research on it myself. And it's something that you see in really old individuals that smoked the majority of their life. And I was like, I'm 21, or I was like 18 at the time, a healthy 18-year-old that never smoked or vaped. So it was like very, very confusing. And also during that time, I worked as a medical scribe and a clinical assistant at a chronic pain clinic. And I was like, I thought that I was going to be working with majority old people, which I was. But then I also had a wide range of age groups. Like I would see somebody in their teens, somebody's in their 20s, literally like through every age group. And I thought it was interesting and also a little concerning because I was like, are people just getting chronic diseases and chronic illnesses at a younger age? And as a genetics student, at the time at least, now I've graduated or whatever, I was really, really interested in why chronic illnesses are happening a lot earlier in comparison to earlier generations. And I guess that kind of like led me down the rabbit hole of like looking into the epigenome and trying to understand it more. And it like specifically how gene expression can determine the balance between health and illness. Okay, so I'm gonna backtrack a bit, right? I want to kind of explain what the epigenome is in comparison to the actual genome, right? So we know our genes are inherited from our parents and it's been passed down for generations. And the genes itself is the actual code that is passed down throughout generation and is preserved, and that's what we inherit. But our epigenome, on the other hand, kind of focuses on how genes are regulated, right? So all our genes are not on at all times, right? And that just like depends on how the chromosomes are structured, methylation and stuff like that. So genes are turned off and on depending on time, environment, whatever. It has like so many factors that play into gene expression. Like your environment matters, your diet matters, your lifestyle matters. So I kind of like to think of the genome as the code, the blueprint for your body, right? And the epigenome kind of acts like a coder. So it tells your body when to express a certain gene and also controls the turn off and on response depending on your environment. And I feel like that's what really got me hooked on genetics in general, and like the concept of genetic engineering, because we had some technology like CRISPR and talons that really just allow you to better understand how genes are regulated, what genes do, and what causes certain diseases. You know what I mean? It's really cool stuff. And when I was in school, it was kind of hard to like learn from just like articles and stuff because all this technology is expensive. And when I started like working in labs, I got more hands-on experience. It was just like a lot more fun that way, and it really just like made me understand it a lot better. Anywho, I got a little off topic there, but let's talk about your biological age in comparison to your chronological age. So your biological age and chronological age are different, obviously. So your chronological age is how many years you live, right? But your biological age is how well your body functions throughout that time. So some key factors in determining biological age is how well your genes respond to its environment. So how healthy and young are your cells, and stuff like that. And to kind of look at how the epigenome and stuff is regulated, people focus on DNA methylation mainly and like histone modifications. And when we talk about DNA methylation, we're referring to like an addition of a methyl group to your DNA, and that silences certain genes. So when you add the methyl group, it silences it. When you remove it, the gene is expressed. So normal methylation helps regulate processes like inflammation, cell growth, and metabolism. But here's where it gets a little tricky. A poor diet, high in processed foods, can lead to abnormal methylation patterns that disrupt the balance of biological aging. So we know that highly processed foods are high in fructose corn syrup and trans fats. Both of these are extremely bad for you, and they increase methylation of genes associated with inflammation and metabolic disorders. So this can trigger chronic inflammation, which not only damages your cells, but also accelerates aging and at the cellular level. It's funny because I'm pretty sure I talk about this a lot. Processed foods have always been the culprit, and like originally processed foods was made during like World War II, I think, and that was just to like have easy access food, and it just like continued off of that because people kept on going back and it was very popular. And now that we know that processed foods can change your epigenetics and also increase the development of diseases like diabetes, cardiovascular disease, and cancer. Like all these conditions are related to age, which means a poor diet could be contributing to accelerated biological age, right? So there's always a connection there. Let me give you guys like a very popular example. So you guys know that there's a whole war against seed oils, right? Like soybean, corn oil, all of that. So these are primarily found in processed foods, and so many studies have shown that these oils can increase oxidative stress in your body, promoting DNA mutation, right? And let me just say, DNA mutation itself occurs naturally because your DNA breaks during, your DNA will break occasionally, and then they have to go through repairs. But it always has like a built-in system that checks it again, right? And on top of that, like when your DNA is dividing, there's chances of mutation due to like base changes or something, you know what I mean? So mutations occur naturally, but increasing oxidative stress promotes more DNA mutation, causing your body to work extra hard to make those repairs. And on top of that, Studies have also shown that the polyunsaturated fats in these oils can lead to epigenetic changes that interfere with normal gene expression, increasing risk of chronic disease. And like, even though the data for these are not overwhelming, nobody really knows long-term effects of seed oils on the epigenome and all of that. I'm just like thinking, why add stress to your body when there are better alternatives like olive oil? It just doesn't make any sense to me. And olive oil has been shown to support healthy methylation and promote longevity when it comes to your biological age. And when I talk about biological age, like I talked to like a couple of friends about this and something and stuff like that. And people always think that I'm like, I want to live forever. It's not about living forever. It's about increasing the amount of healthy years that you have. You know what I mean? So when I talk about like longevity and stuff like that, it's just like trying to be as healthy as long as possible. It's not about I want to live until I'm like 200 years old. That's ridiculous. So yeah, like when I say I want to stay young forever, I just mean I want to be healthy. Okay, so as we all know, processed foods really messes you up. It doesn't just affect your epigenetics or your epigenome. It also affects your hormones, specifically leptin. Let's talk about leptin because she's so popular. So leptin plays a crucial role in regulating hunger and energy balance, right? So when your body produces enough leptin, it tells your brain you're full, right? It's the signaling to stop eating. But here's the problem. So processed foods and fast food interferes with that process. Over time, consuming fast food alters your brain reactions to leptin, causing leptin resistance, right? So leptin resistance occurs when your brain doesn't respond to leptin signals properly. Even though your body produces it, your brain's not responding. It's like we're still hungry. You know what I mean? It'll continue to tell you to eat more, and which triggers chronic inflammation. So high levels of sugar and unhealthy fats and additives and like all that stuff that's in processed food causes inflammation to your hypothalamus, which is the part of your brain that is responsible for regulating hunger. So as I mentioned before, leptin, even though leptin is circulating in your system, your brain would never get the message, or it'll kind of like ignore it, leading you to overeat. And as we all know, like overeating leads to disease, and chronic illnesses in the future, right? And it's funny because it gets worse, right? So processed foods condition your brain to view them as the reward food, right? So it causes a constant dopamine surge. It continues to mess with your natural balance and your natural hunger cues, making it harder to recognize when you're actually full or satisfied. And as I mentioned in a previous episode, it also messes with your microbiome, and now you're constantly craving fast foods or processed food in comparison to whole foods, and you're always going to ignore the healthier option. Do you guys remember that book that I mentioned to you guys? It was called The Magic Pill. I don't know why I just said Bill, by Johanna Har. So he mentioned this German scientist that came to the United States to do research, right? And like some of the findings that he had were really interesting, and I obviously wanted to know more. So I looked up the paper to kind of see what his research study was and his final conclusions, right? So what he did was he was interested on the American diet because we typically eat a lot of fast food. So he was like, okay, like, why is it so addicting? Like, why do people choose to eat these foods? And how does it affect your brain chemistry and your body as a whole, right? So he had 3 cages of mice. One was a control group. One was experimental one, where he introduced like cheesecake, I think, for certain periods of time. And then the last one had unlimited access to cheesecake for a while. So at first, he obviously gave them regular mice food, and he noticed that all 3 groups obviously were eating until they were full, and they would step away. And then when he introduced the cheesecake, first they kind of like sniffed around, and then when they started eating it, like they were continuously eating it. They were like head in. They weren't getting full. They were like constantly eating the cheesecake. And he noticed that in both groups, even like when he, in the mouse group, that they were taking the cheesecake away for a period of time. And when they brought it back, like they were head first into the cheesecake again. So he was like interested. He was like, okay, now they're like overeating, and like they're constantly just like going after the cheesecake. So what he did at the end of the experiment is he would take away the cheesecake and introduce them to their regular food, right? The regular mice food that they were getting. And at first he was like, oh, they're just going to continuously overeat this food because fast food triggers leptin resistance, which causes overeating. And that was like the original thought. He was like, okay, they're going to go head first into the mice food. And what he noticed was they actually refused to eat it altogether. They're like, I don't want this. And it's funny because like you kind of see this in children if you think about it, right? Like, you know, when kids are younger and their parents are trying to force them to eat like broccoli and stuff like that, but then all they want is like candy, pizza, junk food, all of that stuff. And like I'm even like prone to this. So when I was younger, like I did not want to eat broccoli. Like that was just gross to me. And it's funny because it changes your brain chemistry into recognizing food, right? Like it's like junk food is food, while whole food is never going to give you the same satisfaction because it's not going to give you a dopamine hit like that sugary ass cookie that everybody's eating, you know what I mean? So yeah, I feel like that's why it's just so important to be mindful of the food that you choose to eat, because it has such a large impact on your body today and on your epigenome, and it will lead to so many other things in the future. Okay, so let me just say this. Lifestyle changes can actually reverse epigenetic changes. So none of this is permanent. Just because like when you turn on a gene or turn off a gene or have like a abnormal DNA methylation pattern, over time you can regulate that and go back onto like a regular DNA methylation style as well. So when we do preventative measures, we can reverse the negative effects of processed food on our genome by changing our diet. I know I mentioned this a lot, but change your diet into eating whole foods and reduce the amount of like processed foods that we take in, especially like hyper processed foods. So whole foods are rich in vitamins, minerals, antioxidants, and they support healthy methylation patterns. So for example, like folate, which is found in leafy greens, and vitamin B12 found in eggs, fish, or like fatty fish in particular, help maintain proper methylation. Another thing that you can do to balance out your biological age is exercise. In a society where we're all working from home, working from our computers, we sit a lot of the time, and we don't really have to do manual labor, is a little dangerous. So incorporating regular physical activity can reverse some of that negative methylation changes by promoting cellular repair and reducing inflammation as a whole. And another major one, would be reducing your stress. You guys, stress is a silent killer, right? So chronic stress can lead to harmful epigenetic changes. So practicing mindfulness and engaging in stress reducing activities like meditation, yoga can always help protect your epigenome from negative impacts and also improve your mental health, right? Like I'm telling you guys, small changes that you can do in your lifestyle would improve your life significantly. It's just crazy to me. Okay, final thoughts. Food is information, right? The nutrition that you consume provides the building blocks for your cells and allows them to function properly. So a diet full of processed foods sends the wrong message to your body, leading to dysfunction of gene expression and also accelerates your age, right? We don't want to be sick when we're in our mid-30s. It's not fun. And balance is key. Like I feel like that's just something that I live by. It's just like making the right choices for you. Like if I'm craving like a cookie one day or like some sugary snack, sure, but then having that every single day will have like long-term effects on you. Processed foods might be very, very convenient, but they always come at a price, and that will be your long-term health. So make the right decision for you. Eat the better option and just like take small steps into bettering your life today, and it will have such a good impact on you and you'll thank yourself in the long run. Honestly, I can talk about this all day if you guys would let me, and I didn't have to end this episode because it's getting too long. And honestly, this episode was more sciencey just in general. So let me know if you guys like these episodes or if you guys want me to tone down the science talk a bit. I don't know. I'll see. So I'll end this episode here. If you like this episode, don't forget to leave a comment and a review. You can always follow me on Instagram for more updates at ANPOV. Thank you so much again for being here with me today, and I hope you guys have an amazing day, and I will see you guys in the next episode. Bye guys.